Hello, this is Philip Petir Fanous, and I'm going to be presenting my video assignment for sampling techniques. So to begin, I'll start with simple random sampling. So essentially what simple random sampling is, it's just like how the name states. What you do is you take random samples in the box of samples, just like we see here. So I just circled random ones, and I got them. Now, after getting the mass for about 20 samples that are completely randomly chosen, I take all of them together and then I divide them by the total number of samples. So I added every number together and divided it by 20 to find the average mass of this. So here's the sample calculation right here, where it shows that I added all of them and I put them in brackets to show the proper notation, and then you divide it by 20 to get the final average mass. Then we have systematic random samples. So in this case, you do it based on every number. So I decided to do every single 5 tiles, I'd circle a new one. So we start with the first section, then you go 1, 2, 3, 4, 5, and then you circle here, and then you go 1, 2, 3, 4, 5, and you essentially follow a systematic order to get the samples for each number. So I did the same thing here. I just continued following the order till I filled up all 20 numbers. And in the end, I took all the numbers together, divided them by 20, added them all, and then divided them by 20 to get the average mass in this case, which was 17.15. Next, we have cluster random sample. So basically, in this one, all you have to do is you take a cluster all together, and that's it. So right here, you can see the different clusters. So I picked this cluster, this cluster, this cluster, and this cluster. Sorry, it's very messy. I was very confused at first. So to begin, you take the random clusters. So I added them here, the first 5 cluster, the second 5 cluster, the third 5 cluster, and the fourth 5 cluster. Now with that, same thing to calculate average mass, I added all the numbers together, divided it by 20 to get 17.25. Then finally, you have a stratified random sample. Now for stratified random sample, you essentially do, out of each 5 options, you just pick one random one. So right here, you can see there was 5 options, 15, 17, 15, 14, 20. I picked 15. And then you continue doing that for each box until you get the total of 20 samples in this case. So it was perfectly fitting for each box. You take one and it creates 20 samples. And so I picked a bunch of random ones, and in the end, I got 17.45 by adding all of them together, same as all the other ones, and dividing them by 20. So then next, we have the final one, which is convenience sampling. Essentially, all it is you add all of them that are right next to each other all together, the first few, and then just put them on the list for the first 20. So I took the first 20, put them on, divided them all. And then I added them all together and then divided them by 20, and I got 16.10 as the average mass. So now with all these average masses, I summarized it over here on the board, and then you could see the average of 5 samples. So just like how I was calculating average before, I added all of them together and divided it by the number of things we're adding together. So in this case, I divided by 5. So by dividing it by 5, I got 17.10 kilograms as the average. So now how close was this to the actual mean, which is 17.1? It was actually very conveniently exactly the exact mean that the total was. And with this, you can kind of see the power of random sampling and how accurate it is to the total mean. Thank you for listening to my video.